Well, I don't know. It feels pretty good having Toby introduce you, don't you? I mean, it just adds credence to anything you're going to say.
Yes.
And I know it'll be brilliant. Thomas, welcome to Cleveland, just
you
like
for
sunny
having me.
California, right? We ordered this beautiful weather for you, and so appreciate you coming into town, early arrival, late going out, giving us your whole day. We're so excited. I know our audience is really excited to hear about what you're doing at Google. You've been there about a year in your, well, no, 2 years, but a year in your role as CEO after 20-some years at Oracle.
Yes.
An engineer at heart, so through and through. But you've got some exciting things happening at Google as you really build this enterprise offering, both in infrastructure solutions, analytics. I know we at Key are truly enjoying our partnership, doing some very innovative things, and could not thank you enough for that. So again, welcome.
Thank you for having me. It's delightful to be here with all of you in Cleveland. And I have had a wonderful day so far.
We've learned a lot about our community. I know that, right? We've seen a lot of my peers, I know. So we're going to have a little fun. I have all these questions I get to ask Thomas on our collective behalf. And he said nothing is off limits, so I will follow the script as much as I can, but we'll see how that goes. But let's just start with some grounding, because as you and I were talking about, I know for Key, 5 years ago when we started mapping out our our cloud strategy, Google was nowhere on our map, right? I mean, it wasn't even somebody you would consider. So for those of us not familiar with Google Cloud from the enterprise, give us an overview of the platform you're offering and maybe the differences between you and some of your competitors.
Yeah, Google's first data center was built back in 2003. And it's got a huge network of data centers around the world, and it offers all of you use our services, whether that's search or YouTube or maps. Starting roughly 5 years ago, they started evaluating what would it take to offer customers the solutions to solve their enterprise problems. And when we look at enterprise, a lot of what we're trying to do with our cloud is industries are being changed through digital technology, and people want solutions to use digital better. So we at Google are doing 3 important things. One is give you high-scale infrastructure. We offer that in 22 regions around the world. We're expanding to another 15 to 18 regions over the next couple of years. We offer compute, storage, network elastically. And we also allow you to deploy a cloud inside your own data center if you want, if you've got applications that need to run inside your own data center. So that's the first piece we offer. Above that, Google has a lot of tools to help you manage and use data better. So we've got databases to handle transaction processing systems. We have tools to allow you to manage large-scale, what's called big data clusters with things like Hadoop and technologies like that. We've got a high-scale data warehousing service that many people use to do analysis better. We've got AI and machine learning tools. And we've got solutions to help people build really innovative applications. When I say innovative applications, you can talk to the application. You can build applications for iOS and Android phones. You can build applications that have virtual reality embedded. You can use applications that allow you to take pictures and search things using pictures and video frames. So very, very advanced application development that's made super simple because you just write code against an API and don't have to worry about actually deploying and managing any of that infrastructure. And then lastly, we're taking our expertise in machine learning and AI and delivering it as solutions for specific industries: retail, financial services, manufacturing, and media as examples, as well as healthcare. So a lot of our goal is let people use our data centers to run mission-critical enterprise workloads, things like VMware, Oracle, SAP, et cetera. Second, give them a set of tools to understand data and use data at scale more efficiently. And lastly, make this easy for people to do by delivering specific solutions for specific problems in different industries.
So when you talk about enterprise, let me just clarify, because you've got a lot of different variety represented in the audience here. Talk about the scale of the enterprise that you would service. Who are you looking to sell to?
So we have customers from, if you look at the different industries in the world, 9 of the top 10 communications and media companies, the largest ones in the world, run a significant part of their business on Google's cloud. 8 of the top 10 retailers, 5 of the top 10 financial institutions, 7 of the top 10 manufacturing companies. So we serve some of the largest companies in the world. At the same time, we serve all the way from there down to small and medium businesses. We have almost 5 million businesses with less than 50 employees running their business on our cloud as well. So it's a huge range,
right,
all the way from the smallest companies to the largest. And our aspiration is to let people grow with us as they succeed from being a small company to being a large one.
And I heard you earlier talk about how you've designed or are designing your processes for the enterprise to be frictionless at each of those scale points, if you will, which I know is music to all of us as we buy from people like you.
That's right.
So when people in my seat and others are trying to make decisions around cloud providers, a lot of folks are talking about multi-cloud.
Yes.
So why do you think that's important? Why do you support it, endorse it, or not?
I think the simple thing we believe is customers should have choice of a cloud provider, and they the 2 problems we are trying to solve as Google. The first one, the biggest impediment to helping people adopt cloud today is a lack of skills. And if you have pockets of skills, you have an Amazon group, a Microsoft group, a Google group, pick your favorite other cloud provider group, it makes it even harder for people to be able to learn cloud, because now you have pockets of expertise associated with each cloud provider. Second, if you decide to start with one cloud provider and you find that they're not delivering you with the best technology, you should be free to move to another cloud provider, not be locked in. So, when we look back at computing and we look back at the history of computing, the example we give people is before the programming language Java existed, when you built an internet-based application, you were tied to an operating system. And then Java came along and said you could write a program once and you can run it on any operating system. So it broadened the talent pool of developers that were available and also gave customers choice. Now, we've done something similar for cloud computing. We've invented a technology that lets you do 2 very simple things. First, you can start by running our cloud inside your own data center if you want. You can move workload up to Google. You can also move workload with the same technology to Amazon and Azure. The only thing you have to do when you move workload is not to change a single thing, because we operate consistently no matter where you run it. The second is the technology that we invented was called Kubernetes. It's an infrastructure to run containers and virtual machine orchestration at scale. Not only have we given you that, but we've given that in open source, so you don't have a dependency on Google. The second thing we've done is we've made the administration and security consistent no matter where you run. Because the other challenge we heard from administrators was, sounds great that I can spin up workload across these environments, but if I then need to manage these environments, I want to secure these, can I do it in a consistent way? Because otherwise, I will have security holes in how I run my operations. So we've also added administrative capability to allow you to secure, monitor, and manage in a consistent way. Through that, we believe we're giving customers the best of both worlds. You get to train your people on one technology that's independent of any cloud provider. Secondly, you have the insurance policy that's available in open source. And lastly, you get to accelerate how quickly you move workloads, because now you have a broader pool of developers who are trained on technology that can run on any cloud provider.
So I know we are Kubernetes clients and are working with you on your Anthos rollout and are very, very excited about what that will do for our deployment of our own web-facing applications for our clients and making it so much easier to deploy for our clients and faster. So we appreciate that. So you mentioned earlier, I mean, Google is so well known for AI and analytics, and probably more from the consumer perspective. You know, I've got my Google search, I have my maps, I have those things that we all love to use, and it's all powered by some amazingly brilliant data scientists. You named something like 9,000 of them at Google. But how are you helping clients like all of us take advantage of that incredible intellectual capital that you have at Google?
So we're trying to make machine learning and AI really easy for people to do with two important things. First is we're taking our foundational building blocks, which is speech, image processing, video processing, et cetera, and allow you not to have to be a data scientist to build a model, but through something called AutoML, the machine will build the model. And the machine will build an incredibly sophisticated model for you, and all you need to do as a data scientist or as a person trying to build a solution is tune some parameters. So, and our AutoML is so advanced now that in many, many places it beats the best data scientists. So you can trust that the software will build you a great starting point as a model. So the first step we wanted to give people was make it super easy for people to be able to use models by having the software do a lot of the heavy lifting for you, and you can then tune it. The second thing we're doing is applying machine learning and AI in a bunch of places through prepackaged solutions. And prepackaged solutions, I'll give you 3 really simple examples. I'm sure some of you eat pasta, right? One of the leading pasta manufacturers in the world found that their manufacturing shop floor was not running fast enough. And the reason it was not running fast enough was human beings were inspecting the pasta to see was it of good quality or not. Most of it was it broken or not? We helped them by putting a camera on the top of the manufacturing line. It allowed them to run their manufacturing flow as fast as possible. The camera is taking pictures of the pasta as it moves, and it's comparing good pasta against a picture of what is considered good, and through image recognition, it's allowing the manufacturing of pasta and the satisfaction of people eating pasta to be really, really good, right? A really mundane example of how image processing is helping manufacture. Second example, many people in the media industry work with Google. One common place that they've asked us to help them with is with sports. The challenge people have with sports is they record a 90-minute sports game. At the end of the game, everybody knows the score. So that TV recording, very few people want to watch all 90 minutes of it. To then throw it away is an extraordinarily expensive proposition. So what they wanted to do was take that movie, take that recording, strip out advertising because they don't have copyright to rebroadcast it, play the video through an automatic system based on computer vision that watches the movie. It records every frame and can tell you exactly what's happening in every frame. Like in your world, so-and-so threw a forward pass to so-and-so in the third quarter, and it scored a touchdown.
I was hoping you were going to go somewhere it's going to help the Browns perform better. I don't think that's where you're going, though. Not to interrupt you, I'm so sorry, but I'm like anxiously waiting for him to go. Okay, keep going, I'm sorry.
So you could, for example, say, find me all the frames that have the quarterback throwing a forward pass to this particular receiver, and it'll automatically splice those into a short format and make it rebroadcastable. in like 8 minutes instead of an hour. So it's taking media assets that in many cases were not considered live or useful and giving them back life because they can be rebroadcast, and no one would watch the hundreds of hours. No human being is going to watch the hundreds of hours of film. It's just naturally done. Third mundane example, how many of you call a contact center? Okay. How many of you said, when I called the contact center, it was the most amazing experience I ever had? So, we've worked with a number of solutions over the years to understand what's affecting contact centers. And it's a very important problem because everyone talks to customers, and frankly, most consumers interact with a company through its contact center. So we said, how can we both make contact centers better and improve customer experience? So here's what we invented. We took Google's speech recognition, language processing, and other technologies, put it together so that you can dial a 1-800 number. A software agent will answer the phone. You can have an infinite number of those software agents. They're not like people, they're just software processes. So your wait time in the contact center can go to 0 as a consumer. You can talk to the agent. It asks you, how can I help you? You can say, I'm trying to find the status of my package because I'm trying to understand, will it be here before Christmas? Please give me your package number. You can have a conversation with it in 9 different languages. It will look up the package information and give it to you. If you get stuck in a conversation with it, it can say, I'm stuck, can you please get me help? And it'll hand over to a human being. When it does, it hands over to a human being with the entire transcript of the call, so you don't have to go through the whole explanation all over again with a human being. Now imagine you could do that where you never have to wait for a contact center call to be picked up. You get 98% fidelity in speaking multiple languages, and it can displace a lot of things that human beings find super mundane to do, like type in your purchase order number and track a package. This is all stuff that's based on Google's advances in understanding speech, voice, language, images, vision, put together for you as solutions so that you don't have to take hours building a contact center automation solution. We can give you one.
I know we've taken advantage of that at Key, and we launched somebody we call affectionately Penny, and Penny helps now reset all of our passwords internally, because it was a call that we would get to our internal help desk consistently, and so now Penny can just reset that for us, and it's a much more pleasant experience. I liked your examples too, because I think all too often we are talking about AI and cloud in terms of Uber and these industries that are being radically transformed, and yet there are real solutions that we can apply to digitizing our own processes. Absolutely. Powered by that machine learning that can either make it a better client experience or make our processes more efficient, like your pasta example.
That's right.
So,
and we believe that the biggest opportunities are to help organizations that are not digital natives, that were not born in the cloud, actually transform the business. Now, since it's Christmas season, one example of something that we're super proud of, or two, we ran a huge part of America's retail on our cloud during Black Friday and Cyber Monday. And it was largely about providing resilience, elastic capacity. So if somebody had a great product and they were worried about, will I run out of capacity to process peak load, and to improve the performance of retail so that traditional retailers have a good experience. Obviously, one of the unfortunate things of ordering lots of products is they have to be delivered.
Yeah.
So an example of a company we've helped on the delivery side is UPS. Now, UPS has lots of trucks that get dispatched every day to deliver packages. They used to take many, many hours to calculate how best to route the trucks. And they could only do that once a day in the mornings because it took them many hours to calculate how to position the fleet. Now imagine if a truck breaks down, you've got to dispatch another truck and reroute the packages. So you need to reschedule the fleet in that local area. It used to take them 7 to 8 hours to calculate the position of the fleet. Now they can do it using our analytics infrastructure in as little as 4 minutes. So not only do they have they saved a lot of money, but their consumers get a much better delivery experience, and they're also able to use things like traffic information to figure out what might be the real time it takes to get a truck through that day. While if you were planning on a 7-hourly basis, you have no way of folding things like traffic, which is real-time information, into this analytic model. So there's lots of incredibly pragmatic things. When you receive that package, hopefully from UPS for your Christmas, for your Christmas gift, you can think of how that's happening behind the scenes. And that's a really practical example of using analytics, but in a real-time context to solve an incredibly important but mundane problem.
Yeah, but simple, right? So how do you balance the need for all this innovation with the need to be safe and secure, especially when you mentioned, well, most of the industries you mentioned are regulated by somebody, but if you have healthcare or financial services or some of the manufacturers that have really important IP, how do you balance that? It's always in the news.
Yes.
Is cloud really more secure? How do you help with that?
So we at Google have many, many years of building technology to protect Google services from cyber attacks. You can imagine if you are a bad actor, one of the services you would like to shut down is Google Maps, because people wouldn't know where to go. And then another one would be Google Search, because people couldn't even find anything. Yes, and it would give you instant fame. So how many of you have seen Search or Maps down? And it's not by pure happenstance, it's because we have a lot of technology that protects those services. So we have brought a lot of our expertise to the enterprise by bringing a number of cybersecurity services to protect customers' data. A simple thing is, a belief is the following. The first one on data. Data is the new currency in the digital world. And so we need to protect your data. So when you as a customer put data in our cloud, it's encrypted by default. In fact, if you don't want it encrypted, you have to explicitly tell us you don't want it encrypted and why. You encrypt by default, you manage the encryption keys, you store the encryption keys in a hardware security module, which is like a cryptographic store. We do not have access to that store. If you want Google to help you with anything, we explicitly request your permission, and then while our operators are doing something, we send you a live stream of what they're doing, so you get absolute crystal clear what are they doing, and they're given access only for 24 hours, after which we shut off access. So you have complete transparency on how to manage and secure your data. Second, we have a number of tools to allow you to do intrusion detection, monitoring, as well as cyber defense. One example of something that a lot of people ask us for is to identify not just external threats, but insider risk. Insider risk is one of your administrative accounts, like a database administrator, that account was compromised. You don't know it was compromised, but somebody happened to get access to those accounts. Those are super privileged accounts because a database administrator has access to lots of resources in your organization. They can run queries, they can look at data. How do you detect if an insider is doing things they were not supposed to be doing? Now, that's a very complicated question to answer properly, because if you detect a lot of things and raise false alarms, people start getting tired of the tool. So you have to be incredibly accurate in detecting signal from the noise of day-to-day work, and we have tools to do those kinds of things. So we believe that for cloud to succeed, it needs to be at the highest level of security, data protection, and regulatory compliance. And we are compliant with standards for regulated industries, governments, consumer products like PCI, HIPAA for healthcare, FedRAMP for government, as well as financial services regulations in many countries, and we continue to push the boundary of that. But our goal is not just to meet the regulatory standard, but to solve the security problem beyond what the regulations may require.
Yeah. And it's a challenge for all of us, so we appreciate that. You talked about data being the currency. Clearly, it is something that I know all of us are trying to figure out. How do you turn that asset into something that's insights and intelligence that could differentiate? But to do that, I would say then talent is the fuel, right? Mm-hmm. So how do you compete for the best talent at Google? And how do you then help as you interact with your clients to have the top talent to leverage your services? So talk about the talent in the tech industry in general.
You know, at Google, we have a very interesting culture in the way we nurture engineering talent. You know, our goal has always been to give our engineers some boundaries within which to work. What problems should we look at and what problems should we not look at? Because we have to get critical mass behind a set of important problems. But one of the things we have built into our culture is this notion of having broad imagination, so that they get to imagine solutions to problems that could never have been imagined before. Like, I'll give you an example. It was 15 years ago, April 1st, 2004, when Google imagined that people should be able to do email from wherever they are. And they said the easiest thing is to let people access and send mail through a browser. And at that time, if you went back 15 years ago, you could hardly do anything through a browser outside of look at web pages. To make a bet that you could do email from anywhere you want with a device without requiring a desktop and a fat client was a remarkable leap of imagination by a set of people. Another engineer who had the idea to say people should not be afraid of finding their way. Mm-hmm. Let's help them find their way by giving them a mapping tool, not just for certain cities, but the entire world. Recently, we've done a lot of work as Google for the last several years to improve accessibility. And I'll give you a simple example. Today, if you are a person with disabilities, it is super hard to actually use computation, particularly because almost all computation for output, you can look at screens, but input, you have to type. And many people with disabilities can't type. So there are various kinds of screen readers and various other technologies, but they're not as good as a natural language interface. So we've been working for many, many years to say, can we imagine an input device that's as natural as speaking? And when we say as natural as speaking, that transcribes you literally as you speak. All of these have come from putting a problem in front of a set of engineers and letting them imagine a big leap forward in the kind of solution they can deliver. So that's a big part of the culture of the company. It really helps us attract talent because people want to work at a place where they can imagine solutions to problems and push the boundaries of what problems they're trying to solve. When we work with customers, our central thing is, if you look culturally at what we're trying to foster as a cultural notion within our organization, the central thing we're focused on is something called customer empathy, which is before we provide a solution, before we think of a technology, try to deeply understand what's the customer actually trying to do and what's the problem they're facing, because through that, we can identify what will be the right solution to that problem. Mm-hmm. And if we can do that well, we have a lot of experts we can bring to help customers, but I think that's the most important element for us to understand. And we've been blessed with a great team. We brought a lot of people from enterprise companies who have been in the software business for many, many years to build out our team. And we are really getting them engaged with our leading customers. And we've been fortunate that so many people have wanted to do that.
I want to applaud you, though, too, Thomas, because I think one of the things we've noticed working with you over this past year is there is that curiosity you talk about in your culture. You're also accepting and discussing that with your clients and allowing your clients' curiosity to be brought to bear and your clients' expertise to be brought in without saying, well, wait a second, we're Google, we know everything. There's a genuine interest and not an arrogance that, hey, maybe that healthcare client you're working with actually has more in-depth understanding about healthcare. Take their curiosity with yours, and together the solutions can be even more powerful.
Yes.
That's at least been our experience, and where you're co-creating.
Yes, exactly.
With the talent.
And our vision is that, Google cannot be everything to everybody. We have technology expertise, but what we want to do is help people through organizations. So we're not going to deliver patient care. How can we help doctors deliver patient care better?
Right.
We're not going to manufacture products except for Pixels and Nest devices. How do we help people who want to use our manufacturing, our analytics infrastructure to manufacture products better? And so a big part of the excitement that we get as an organization is understanding the problems that our customers have and then co-creating, as you said, some of the solutions. That's super exciting for our engineers, and it's frankly what gets them up in the morning.
Yeah, and I would just encourage the audience, I find it super exciting for our teams too, to be able to co-create, and again, that the talent together is more powerful.
Yes, and
So
your
I
team
think
has been great to work with.
Yeah, it's kind of fun. So you're talking about technologies. As you look into 2020, what are the tech trends that you're most interested in, or what are the ones that concern you the most? And it could be stuff that you're doing at Google or not. Just what do you see?
The technology trends, I think the biggest thing that we're focused on is trying to make cloud much easier to adopt. We think that today it's not that technology doesn't exist for a set of problems. It is how do you make it easy enough that everybody can use them, right? And so whether that is AutoML, our industry solutions, what we're doing with our serverless infrastructure, like for example, our view is for many applications that you're building new, human beings shouldn't have to worry about how much compute or storage to provision and manage. You should write your application and deploy it. And as transactions come into that application, the infrastructure should auto-scale to meet it. And you don't have to worry about, oh my God, I need to provision 22 virtual machines with 16 terabytes of storage to support the application. So everything we're doing is about two basic philosophical things. Try to make it easier for people to adopt technology by simplifying it and eliminating complexity and better integrating pieces together. So that's a lot of what we're doing on the infrastructure thing, and infrastructure side, for example, multi-cloud, what we're doing with serverless, what we're doing with edge computing, what we're doing with analytics, all of it's designed around that principle. On the sort of longer term side of things, the area we're spending time evaluating and understanding is the area around quantum.
Quantum, yeah.
Right? I think our general view is that traditional computers will continue to do important things for specific workloads to make them more efficient. There are two kinds. One is where, for example, in artificial intelligence, a lot of artificial intelligence operations in something called neural networks, at the bottom, they translate, ironically, into mathematical matrix multiplication. And so instead of trying to use a general purpose computer to do matrix multiplication, we've invented, along with some partners, a special processing unit that runs matrix multiplication super fast. And that lets you do AI much more cost effectively and frankly, much more energy efficiently. On the quantum side, a lot of our view is that certain kinds of computational operations, even if you had an infinite amount of traditional compute capacity, would take a super long time to compute. And so we wanted to build a new kind of infrastructure that lets you handle computations of those kinds, but with much faster time to completion. And so recently we made an announcement around what we call quantum supremacy, which is the early proof of existence of a kind of mathematical calculation that can be done in an incredibly discrete unit of time, a few minutes by a quantum machine, that would take years for an extraordinarily large number of traditional computers to calculate. Now, the big thing that we're now looking at with quantum is how to industrialize it. Industrialize it is what kind of programming models do you provide? What kind of programming languages should we provide? Are there techniques we need to provide for exception management, et cetera, and to move it from the realm of scientific computation to general purpose computing. There's a lot of work we're doing there to evaluate what we need to do to bridge that gap.
I still haven't gotten my head around it, I'll be honest with you. I mean, we've talked about it a little bit, and I'm starting to read more and more about it and trying to figure out the application. And then so many articles around quantum also talk about how it could be used in the wrong way. So we'll have to understand the security and what it could be used for. So that's, it's out there. I'm glad you guys are starting to think about it. We're at a blockchain event, so what role does cloud play in, do you think, taking blockchain and that technology further than maybe where it is today?
Yes, so we have a number of customers who have deployed blockchain for enterprise scenarios on our cloud. When I say enterprise scenarios, things like they want to handle supply chains in a distributed way, and they're using the Hyperledger as an infrastructure to handle a distributed supply chain. They want to handle a logistics network. They want to handle inter-country financial transfers, et cetera. We see ourselves providing an infrastructure to let you run a blockchain with extremely good performance and security. There are specific things we're doing to optimize how efficiently, when you're running a very large, not batch, but transactional Hyperledger, with things like consensus, ordering, state management, et cetera, that our infrastructure can support that really well. And we work with a variety of partners to build solutions that those partners offer on top of our infrastructure substrate.
Interesting. So two other quick questions. One, this wasn't on the script. I see you're wearing a band that says happy birthday. Tell me it's not your birthday like today.
No, I have an 11-year-old boy.
Okay.
And we made this for him for his birthday. And I promised him I'd wear it for next year until he was 12. So
That's awesome. Isn't that awesome? That says something about your character, and I know you and your wife are incredibly devoted to your son. So, but I had to ask, I was thinking, boy, if he's here on his birthday too, then we're gonna have everybody sing. So we'll say happy birthday to your son. So as we close, I want to just think about what challenge might you give or advice might you give this technology community? You've got entrepreneurs, you've got enterprise, around the velocity of change. You've been in this business a long time, and it's pretty frenetic now, isn't it?
Yes.
Compared to maybe when you started 20-something years ago. Give us some advice on that.
Yes, I think if you went back 10 years ago and you said what % of the world would be accessing their day-to-day activities from a smartphone, what do you think your bet would be? 2008, 2009, it was like 3 years after the original iPhone came out. Not many people would say that would be the dominant thing that we would see people using, right?
Yeah.
If you went back 10, 12 years ago and said what % of the world would be considering cloud as the dominant way to deploy their enterprise applications, probably not a lot of people. If you said 10 years ago, can I imagine that I could speak to a phone and have it translate from English into Spanish for somebody else without any delay, meaning in real time. Somebody would say that'll never happen. All those are possible today. So the biggest things, though, that we see, the heart of trying to deal with technology disruption is identifying those technologies that will last for a long time, right? And the ones that always succeed in the end are those that materially change convenience and economics for either a company or for consumers. Like if you look at the smartphone, what it did was it allowed you to have a computational device, easy to carry, far cheaper than a computer in many cases, and always with you. But it was not just that. It also converged a camera, it converged a calculator, it converged a whole bunch of functions into that device. That's why it's been a lasting device.
Right.
If you look at cloud, for example, what its promise is that people don't have to have data centers in order to access technology. They don't need armies of people who know how to provision, manage servers and storage. The technology that we use to run Google, we want to make available to everybody, so that you could use the same technology that powers search. You can literally use it. And so that changes the availability of very powerful technology at an incredibly cost-effective form factor to everybody in the world. And to us, when you as a developer or an engineer is trying to look at the range of technologies out there and trying to figure out which ones should I really learn and which ones are going to last for a long time, the ones that always succeed in the end are those that change how easy something is to do, how convenient it is, and how much economically it changes how easy it is for somebody to do something. Other technologies come and go. There are many, many technologies. When I mentioned since 2009, I didn't want to put up the losers gallery because that's never polite, but there are many technologies that have existed in 2009 that no longer exist today. Right? And you can look at that and go, okay, why did they not succeed? Eventually it falls down on one or two of these key questions.
And I think the other piece that we were talking about earlier too is just the amount of change that people have to absorb to be able to do this. So going back to our talent questions, our talent discussions, all of us have to be so much more ready to think about those questions and then learn those new technologies as we're going along the way, right? I mean,
And the amazing part is there's so much training, certification, and other things available now. The heart is knowing what you want to do as a person, what are the technology you want to learn, and how do you learn it? Just to give you an example, last year we certified, not trained, over and above training, we certified at the master level close to 300,000 people. If you think about that, that's more than 1,000 people a day.
Right.
And it's an extraordinary number of people, and it's not because they came to classes. They went online, they tried the labs, they spun up environments, they learned it, and those people now have great opportunities to use this technology and further their careers. So
you all did that. You made that available for free for people to go out and
it's
anybody
available
could
for
go
free.
on there.
The big thing I would tell you is the same way that you now have very powerful technology available to you, there's the enablement on this technology that is also available through you. And the suggestion I would have is find a project, find a problem that you find compelling, go use it. One of the people in our group, just as an example, she's a very smart individual. She's a person developer in our organization. She wanted to learn how to spin up a large-scale Kubernetes cluster. She took a problem that was dear to her heart, calculating pi, the number pi, to 1 trillion digits. Believe me, you need a reasonably large cluster to do that. And she did it in a weekend. And before she did that, she had no idea about
Kubernetes or how to do it.
But when she did it, she found it super exciting because it was a problem that she genuinely understood and wanted to learn. And it was the combination of her passion with learning a technology that was the heart to it.
I love it. I think that's a great place to end because I think it's a challenge that each of us can accept personally is to go out there and figure out one thing to problem solve. And we can go out there on your training and figure out how to do it. Ladies and gentlemen, please help me thank Thomas Kurian for joining us today.
Thank you. Thank you so much.